Okay, so this video is going to start us off in section 9.2, the unit circle and its functions. So we're going to start with the unit circle, and hopefully this is somewhat familiar to you, at least if you took college algebra. So the unit circle is a circle centered at the origin with radius equal to 1. That's why it's called the unit circle, because radius is 1. And if you remember your circle equation, it is x minus h squared y minus k squared, where that's your center. So since we're centered at the origin, it's just going to be x squared and y squared. So x squared plus y squared equals r squared, and r squared is just 1. Okay, so we have a circle centered at the origin, and the equation would be x squared plus y squared is equal to 1, and it's got radius 1. And we labeled these before, so we had 1, 0, 0, 1. My circle's a little bit wonky here, but you get the idea. 0, negative 1. Okay, so we had those labeled before. And then we also know from talking about radian measures as far as angles, this is 0. Actually, let me do this in another color. 0, pi over 2, pi, 3 pi over 2, and if we kept going, this would bring us back to 2 pi, and we could, mark other angles and stuff, but that brings us back to where we were. Okay, so we've labeled, this much we've labeled before. Hopefully you've seen the equation of a circle before. All right, so one other thing to note is that if you are on the unit circle, remember we had S equals R theta, where theta is in degrees. If you're on the unit circle, then your radius is 1, and S is going to be equal to theta. Okay, so if you're on the unit circle, your arc length is the same as your angle. So we looked at these numbers in red, we looked at these values in terms of angles, but it would be the same as talking about arc length. So if we talk about arc length instead. My default is to talk about them as angles just because that's the way that I learned it, and that's the way that you primarily use sine and cosine. So if I say theta or x, just know that those are mostly interchangeable. This book approaches it from arc length, so that's why we've been talking about that so far. It's just a different way to think about it and approach it. So we're going to look at this from the concept of arc length first. Okay, so let's draw this over here. So same thing, unit circle. That one's just getting a little bit crowded. All right, so we talked about these key points that are on the axes. And you can also have lots of other points, infinitely many points on the circle. That could be any value for x and y. Okay, so the radius is still 1. I'm not going to write that every time. That's just implied. So we could have any point on the circle labeled x, y. Okay, not just these 4 that we know how to find. So from these points x, y, we're going to define x is equal to sine s and y is equal to cos. Oh, no, backwards. Sorry. X is equal to cosine s, y is equal to sine s. Okay, so these values as we move around the circle, they're going to be based on this arc length that's right here, okay, which is interchangeable with the angle as well, right? But we're talking about arc length. And these points are going to be cosine and sine. So cosine s, sine s. So the first value in your point is going to be your cosine value. The second value in your point is going to be your sine value. Okay, so that's our definition. And then we're going to base some other functions from these two. So I'm going to move these over here so we can go through the others. So we've got, these are our two main trig functions, sine and cosine. And then we base another function, tangent, off of those. So tangent is equal to y over x if you're looking over here. Or in other words, it's sine over cosine. Okay, so tangent is the same as sine over cosine, so it's based on those two. And then the other 3, so these are, the sine and cosine are kind of the main ones. Tangent is also kind of a main one. Those are your main 3. The other 3 that we have are the reciprocal functions. So they're the reciprocals of the ones that we have. So if you understand sine, cosine, and tangent, then you should be able to do the reciprocals. So cotangent, whoops, left off my s. Cotangent is the reciprocal of tangent. Okay, so you just take tangent and flip it. And then you've got cosecant and secant are the reciprocal of sine and cosine. So I remember this as the letters being opposite. So, I'm sorry, I keep going to x's. Sorry about that. We're doing s's. S's. Okay, cosecant goes with sine, and secant goes with cosine. Okay, so remember that it's opposite letters, and you don't have to memorize these anyway, but you're going to have to be using them a lot, so it's good to just know it. But they're opposite letters, so C goes with S, S goes with C. Okay, so secant and cosine, cosecant and sine, those are the reciprocals. All right, so these formula, these right here, I would say write them down and keep them close as you're going through these, at least until you get comfortable with them. We will use them a lot, so if you haven't seen them before, that's okay. You'll probably be comfortable with them by, I don't know, maybe another couple weeks. All right, and as long as we're here and we've got all this written out, I also want to point out that if we look at our first box here with sine and cosine, we can also rewrite the equation of the circle using sine and cosine. So we could write x squared, we would write as cosine squared s. We usually put the square next to the function. It's a little bit different for trig functions. So we could put parentheses and put it on the outside, but we also usually just write it on the inside. So cosine squared plus sine squared is equal to 1. Okay, so that's from between the equation of the circle and our definition of sine and cosine, and that gives us our first trig identity, our first relationship between trig functions. So we know that cosine squared plus sine squared is equal to 1, and that's always true. All right.